Hello guys, welcome once more to class online. My name is Tutorami, and in this edition we shall look at Jamb Physics 2013, and we shall be talking about some difficult part of physics that we shall be clarifying. Don't forget that if you learn something from this video, click on the like button. We have lots of content to share with you that will better help you understand physics. Now in this edition we shall be looking at number 26 to number 30. And we shall be clarifying it. Now, this number 26 says a transverse wave and a longitudinal wave travel in the same direction in a medium have differ essentially in their what. Now, this question is simply saying what is the difference between transverse wave and longitudinal wave. Now, do you have any idea what the difference is? Is it in their frequency or their amplitude or the direction of the vibration of the particles of the medium or the period of vibration of the particles of the medium? Now, any idea? Now, when you were taught about wave, you were taught about two types of wave majorly. No, we were taught about two types, right? Mechanical wave and electromagnetic wave. But under mechanical wave, we have two types of wave also, and that is longitudinal wave and transverse wave. Now, the word longitudinal is a wave that travels in the same direction as its propagation. Like example of such is sound wave. Now, longitudinal wave travel on a straight line. That means it travels straight. Like if you send a sound, it travels on a straight line. Like if you release sound from a speaker, it travels like this, straight. It travels in the same direction as its propagation. But transverse wave does not travel in the same direction. Transverse waves travel perpendicular to its direction of propagation. Like if I say, like example is water wave. So water wave travels this way, perpendicular, up, down, up, down. It moves up, down. So when you release the water, that means when you release the wave of the water, it should go straight, but it doesn't go straight. It goes up, down, up, down. That is transverse. So it is said it is a wave that travels perpendicular to the direction of propagation, while longitudinal wave are wave that travels in the same direction as its propagation, and that is the difference. Now, the major difference between the two of them is their direction, and that's what this question is all about. It's asking what is the difference between transverse wave and longitudinal wave, and the simple answer is just their direction, and that is it. So the answer to that question is simply option C. Direction of the vibration of the particles of the medium is the difference between transverse wave and longitudinal wave. Don't forget, transverse travels perpendicularly. Example is water wave or light wave. Then longitudinal wave travels in the same direction as propagation. Example is sound wave. It travels straight, and that is the answer to that question number 26. Now let's check out number 27 now. What is the velocity of sound at 100 degrees Celsius if the velocity of sound at 0 degrees Celsius is 340 meters per second? Do you have any idea? Now this question is between temperature and velocity, that's speed. Now, what is the formula that combines temperature and speed? Do you have any idea what the formula is? Now, remember that they mentioned sound wave, right? Now, let's check it out. Now, this formula is simply V equals root YRT over M, where the V is speed of sound, Y is the adiabatic index, R is the gas constant, and T is temperature, and M is mass. Now, this formula is found under sound wave, and we saw that in this formula, velocity is directly proportional to the root of time. Like, my question is between temperature, sorry, not time. My question is between velocity and temperature, right? And by the formula, velocity is directly proportional to the root of temperature. So therefore, I'll just pick out one. So the others, Y, R, M, are constant. So I only need V and T because the question is all about V and temperature, T. So therefore, I'll put it out. So V is directly proportional to T. Then I'll write it out this way. It will become V1 over T1 equals V2 over T2. That's if I put a constant there and I make that constant the subject, it will give me V1 over T1 equals V2 over T2. Then I am to find what is the velocity of sound. That is V1. That's the first V at 100 degrees Celsius. That's the first temperature. Then if the velocity of sound at 0 degrees Celsius is 340, so my second temperature is 0 and my speed is 340 meters per second. Now I'm finding V1, right? Now to find V1, I will just make V1 the subject, so it will become V1 over T1 equals V2 over T2 root T2, sorry. It will give me V1 equals V2 root T1 over root T2. Now substitute in all the parameters, pour them in. That will become V1 equals, what's my V2? 340 root, what's my T1? My T1 in the question is 100, so that will become 100 plus 273. You know, you must change temperature to Kelvin, and what you use to change temperature from degrees Celsius to Kelvin is 273, and that is it. So I will change this way, 340 root 273 plus 100, then over root 273 plus 0. You know, my T2 is 0, so that means 0 plus 273, that will give me this value. So if I solve it for that, 340 is 340, 273 plus 100 is 373, over 273 plus 0 is 273. Okay, and that will give me, if you multiply the ones on top and divide by the one below, you will get 397 as your velocity 1, and that is the answer. The answer, sorry, is not B. The answer is supposed to be C, and that's why we have to be careful with some past questions. The answer might be wrong. Okay, so the answer to that question is C, is C, is C, and that is it. That is it. So that is for number 27. The answer is 397 meters per second. Now number 28 says, if a sonometer has a fundamental frequency of 450 Hz, what is the frequency of the fifth overtone? Now the word fifth overtone is the same as the fifth harmony. Now the fifth harmony is given by the formula. You know, under sound wave we also learned what harmony or sound wave, and you know there's a fundamental frequency, or the first word, the fundamental frequency, and then that is FO. Then it begins from what the first word, harmony, and the first harmony is given by 2 times the fundamental frequency. Second harmony is 3 times FO, that's fundamental frequency. Third harmony is 4 times FO, while the fourth harmony is 5 times FO. The fifth harmony is 6 times FO, and that's it. That's the way it climbs up. Okay, now the fifth harmony is therefore given by the formula 6 times FO, right? Now what's my fundamental frequency? That's FO. What's my FO? My FO in the question is 450 Hz, and that will become 6 times 450, and that is 2700 Hz, and that is the fifth harmony or calculation. That's the way. Just multiply. If it is fifth, use 6 times FO. If it is 3, use 4 times FO. If you are asked to find the first harmony, use 2 times FO, and that is the answer to number 28. Now let's check now number 29 now. A man is 1.5 meters tall, is standing 3 meters in front of a pinhole camera, whose distance between the hole and the screen is 0.1 meter. What is the height of the image of the man on the screen? Now this one is talking about a man, a camera, and so on. Now you know that this thing works by the magnification formula. You are talking about height and distance. Have you seen that formula before? That talks about height and distance of an object and the image. Now that formula is a magnification formula. It is from magnification that we get that formula. So now that interface is M equals D, that's distance of image over distance of object, equals height of image over height of object. So any question under wave that discusses distance and height is given by this formula: D of image, that's distance, over D of object equals height of image over height of object, and that is the way to go, and that is what we will use now. Now what is the distance of the image in the question? It is 0.1 meter over what is the distance of the object? It is 3 meter, equals what is the height of the image? It is not known. That's what we are looking for. Then over what is the height of the object? It is 1.5. Okay, now 1.5 is what I have now. Now then what do? You have to find the HI, that's the height of the image. Just cross multiply and make I the subject. That will give me HI equals 0.1 times 1.5 divided by 3, and that will give me 0.15 over 3, and that will give me 0.05 meter, and that is the height of the image of the man, and that is the answer to that question. Now let's check out number 30, which is the last one for this video. A ray of light passing through the center of curvature of a concave mirror is reflected by the mirror at angle 1. Now when on the mirror diagram, when the ray of light passes through the center of curvature, that's C point, okay, now, and it is reflected by the mirror. This is the way it reflects. Can you see it passes through the C? But how did it reflect? It reflected backward on the same line. That means there is no angle between these things. It went forward and came back on the same line. Can you see forward and backward at the same point? And that means the center of curvature is what? Now there is no angle between it, so it came back on the same line. Because there is no angle between the points, therefore the answer to that question is simply 0. And that brings us to the end of this video. Don't forget, if you learned something from this video, click on the like button. We have more content to send to you that will better help you understand physics. Until we see you again, guys, take care of yourself and bye for now.